Welcome to our discussion on Python libraries for data science and machine learning. In today's data-driven era, Python plays a central role in shaping these fields. Python libraries like NumPy, Pandas, Matplotlib, Seaborn, scikit-learn are the backbone of data analysis, the visualization and modeling. In this session, we will explore how these libraries make data science and machine learning accessible to all, from professionals to beginners. These tools are essential for managing, analyzing, and interpreting data, and they are key drivers of innovation in various industries. As we journey through this discussion, we will demystify these libraries, providing insights and practical examples to help you unlock their full potential. Join us in discovering the power of Python in the world of data science and machine learning. At first, we should discuss about NumPy. The short for Numerical Python is a fundamental library in Python ecosystem for numerical and mathematical operations. It provides support for large multi-dimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays. NumPy is a fundamental building block for many other libraries in data science, machine learning, and specific computing. Key features and aspects of NumPy include n-dimensional array, efficient numerical operations, universal functions, broadcasting, random number generation, array slicing and indexing, interoperability, mathematical and statistical function, data input-output. First is NumPy is a foundation library for many high-level libraries in data science such as Pandas, scikit-learn, and for scientific computing in fields like physics, engineering, and computational biology. Its ease of use, performance, and extensive functionality make it an essential tool for data manipulation and numerical computation in Python. Suppose that for n-dimensional array, NumPy's code data structure is the ND array, which allows you to create and manipulate arrays with various dimensions. For random number generation, it includes a suite of functions for generating random numbers and random arrays, which are useful in simulation and statistical analysis. And data input-output also, NumPy allows for reading and writing data to various file formats, facilitating data import and export. Next is about Pandas. Pandas is a Python library for data manipulation, analysis, and exploration. Its core data structures, series, and data frame allow you to work with structured data efficiently. Pandas is widely used in data science for tasks like data cleaning, transformation, and analysis. It excels in handling missing data and reshaping datasets. The library provides powerful functions for filtering, aggregation, and visualization of data. It supports data input and output in various formats, simplifying data loading and saving. Pandas integrates seamlessly with other libraries such as NumPy and Matplotlib, making it a versatile tool for end-to-end data workflows. Its user-friendly syntax and extensive documentation make it a valuable and resource for both beginners and experienced data analysis. Okay, so the next topic is about data visualization libraries in Python. Python offers a variety of data visualization libraries, empowering data scientists and analysts to create informative and visually appealing charts and plots. Some important ones includes Matplotlib, Seaborn, Plotly, Bokeh, Altair. At first, we should discuss about this topic. The fundamental library, Matplotlib, for creating static, animated, interactive plots. It provides extensive customization option. Seaborn is also built the same as Matplotlib, but difference is that Seaborn simplifies creating a statistical data visualization with a high-level interface. Plotly, known for interactive and web-based visualization. Plotly is useful for dashboards and web applications. Bokeh. Another library for interactive visualization, Bokeh, is particularly suited for creating interactive web-ready plots. And some other tools about Plot9, Folium, WordCloud, HoloViews, NetworkX, ggplot. Okay, so that's it. So next library is about scikit-learn. So scikit-learn is a popular open source machine learning library in Python, offering a wide range of tools for tasks like classification, regression, clustering and more. It provides a consistent and user-friendly API for training and evaluating machine learning models, making it accessible to both beginners and experts. Key features include support for various algorithms, model selection, and hyperparameter tuning. Scikit-learn also excels in data pre-processing, feature selection, and dimensionality reduction. It is widely used in data science, allowing users to build, evaluate, and deploy machine learning models for real-world applications. The library's extensive documentation and active community support contribute to its widespread adoption, making it an essential tool in the machine learning landscape. Okay. So, we should discuss about TensorFlow and PyTorch. TensorFlow and PyTorch are the two most prominent and widely used open source deep learning frameworks, each with its unique and strength and characteristic. At first, TensorFlow. TensorFlow is developed by Google. It's known for its flexibility, scalability, and deployment capabilities. It supports both symbolic and imperative programming, offering the high-level APIs for quick model building, low-level access for fine-grained control. TensorFlow's ecosystem includes TensorFlow Serving for model deployment and TensorFlow Lite for mobile and embedded devices. Next is about PyTorch. PyTorch is developed by Facebook's AI Research Lab. It's celebrated for its dynamic computation and graph, which simplifies model building and debugging. It's favored by researchers for its intuitive nature and seamless integration with Python. PyTorch also has a strong community that has contributed to its rapid development and adoption. Both frameworks are suitable for various deep learning tasks including image recognition, natural language processing like NLP, reinforcement learning. They offer pre-trained models, GPU acceleration, and extensive documentation. Translating between them is relatively straightforward as both share similar concepts and are commonly used in research and industry. Some others and important Python libraries about NTLK, Spassy, OpenCV. These are cater for various aspects of natural language processing and computer vision. As first, we should discuss about NTLK or Natural Language Toolkit. NTLK is a comprehensive library for natural language processing, offering tools for text analysis, tokenization, streaming, and more. It includes a wide range of corpora, lexical resources, and pre-trained models for various NLP tasks. NTLK supports text classification, sentiment analysis, parts of speech tagging, and named entity recognition. It is known for its educational value and is often used for teaching NLP concepts and techniques. NTLK is open source and widely adopted and has a vibrant community. Spassy is a popular and efficient NLP library known for its speed and accuracy. It provides pre-trained models for multiple languages, enabling tasks like named entity recognition and dependency parsing. Spassy offers easy integration with deep learning frameworks like TensorFlow and PyTorch. Its similarity simplifies common NLP tasks with its straightforward API and object-oriented design. Spassy is a top choice for developers seeking high-performance NLP capabilities. Next is OpenCV or Open Source Computer Vision Library. OpenCV is a versatile library designed for computer vision tasks including image and video analysis. It offers an extensive collection of algorithms for object detection, feature extraction, and image manipulation. OpenCV is suitable for facial recognition, motion tracking, and augmented reality application. It has a broad user base across academia and industry, especially in the fields like robotics and autonomous vehicles. OpenCV is compatible with various programming languages including Python, C++, and Java. So these libraries are essential tools in the field of NLP and computer vision, enabling developers and researchers to build application and work with text and visual data efficiently. So, in summary, Python libraries for data science and machine learning and AI empowers us in extracting valuable insights and development intelligent solution, from NumPy and pandas for data manipulation to scikit-learn for traditional machine learning and TensorFlow and PyTorch for deep learning. These libraries provide a robust foundation. Python's versatility and accessibility make it the go-to language for data professionals. These libraries play a pivotal role in transforming data into actionable knowledge, enabling applications in diverse fields. As we move forward, staying current with the latest advancement in these libraries is key to harnessing the full potential of AI and data-driven innovations. So thanks for watching, and like, share and subscribe our channel for the upcoming future videos. So good day.